Hey everyone, welcome back to the channel. I hope you guys are doing extremely well. So today we will be solving the problem alien dictionary. What does the problem state? It states you're given a sorted dictionary of an alien language. It's not the English language, it's an alien language having N words and K starting alphabets of a standard dictionary. Find the order of characters in the alien language. Note, many orders may be possible for a particular test case. Thus, you may return any valid order and output will be 1 if the order of a string returned by the function is correct, else 0, denoting incorrect string returned. So let's analyze the problem statement. So basically, it states you'll be given something like BAA, like a number of strings, n strings, and you have to give me the sequence. Now, if I talk about the English dictionary, the sequence is very simple. The sequence goes like A, B, C, D, E, dot, dot, dot till X, Y, Z. And if you follow the English dictionary, these N words would have been something like this. First, we would have had ABCA, then ABCD, then definitely something like BAA, then CAB, and then CAD. Why does this happen in an English dictionary? Because if you see these couple of words, A appears before D, A appears before D, thereby ABCA appears before ABCD. Now, if you go across ABCD and BAA, why does ABCD appear before BAA? Because A is smaller than B, or A appears before B. Now, if you see BAA and CAB, if you carefully see, B appears before C in the dictionary. And if you carefully see CAB, CAD, CCC, this is equal. So B appears before D, thereby CAB appears before CAD in the normal dictionary. But over here, we are not talking about any normal dictionary. It's a dictionary of aliens, right? So it's an alien dictionary. So in the alien dictionary, we are saying BAA, ABCD. BAA appears before ABCD. So we do not follow the standard dictionary or standard alphabetical order of A, B, C, D, dot, 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 X, Y, Z. We have to make our alien order. So the question states, find out the alien order. Yes, the question is very simple. Find out the alien order. And over here, they've clearly stated that K is 4. That means the alien order will have first 4 alphabets from the English dictionary, which is A, B, C, D. You just need to order them. So if you carefully see, this couple of guys are differentiated by B and A. So can I say B appears before A? Can I say B appears before A in the alien order of dictionary? That is the reason BAA is before ABCD. That's because B appears before A. So thereby, in the alien order, can I say B appears before A? I can definitely see this. If I compare these two, ABCD, ABC, so these three are equal. So D appears before A. Can I say D appears before A in the alien order? Thereby, this string appears before this. So D appears before A. So you can definitely write D over here, right? Now let's compare these two things. So if you carefully see these two things, ABCA, CAB, A appears before C. A appears before C. Thereby, ABCA appears before CAB. So A appears before C. So I can put in C over here. Let's see. CAB and CAD. And we are saying that C is equal, AA is equal, B appears before D. So in the alien order, B must appear before D, which is the case. So can I say this is the alien order? Can I say this is the alien order? I can definitely say that this is the alien order. And this is what you have to return. Yes, this is what you have to return. Now, the question is something which says something before something, isn't it? B before D, D before C, A before C, something before something. Which algorithm? Yes, you said it correctly. It's nothing but the topological sort algorithm. We apply the standard topological sort, and if we apply that, we should be able to solve this problem. Now, the question boils down, how do we apply the standard topological sort? So, we know that we have been said explicitly that there are 4 alphabets, the first 4 alphabets from the English dictionary being used. So, I know something for sure that something like A, B, C, D would have been used. So, what I will do over here is I will say A to be 0, B to be 1, C to be 2, and D to be 3. So I express all the alphabets in terms of number. If there would have been till Z, it would have been 0, 1, 2, 3, 4 till 24, 25. So I'll try to express all the alphabets in terms of zero based numbers. A means 0, B means 1, and so on. Now, what I'll do is, at first, yes, at first, I'll pick up these couple of guys, which is BAA and ABCD. At first, I'll pick up BAA and ABCD. So I'll say, okay, BAA and ABCD. And I'll figure out why is BAA. I repeat, I'll figure out why is BAA appearing before ABCD. And the answer to that is very simple. Because B, the aliens are saying B is smaller than A. Thereby, BAA appears before ABCD. That is what the aliens are saying. So I can say B is smaller than A, which I can correspond to a directed graph. And I can say, hey, listen, probably I can have something like a B having an edge to A. We can say that. So we're trying to create a directed graph. So B is having an edge to A. Perfect. So we figured out why BAA appears before ABCD. Now, if BAA appears before ABCD, that's a pair that we have figured out. Now, do I need to again check for why does BAA appear before ABCA? There's no need. Because if we check for BAA and ABCD, we are satisfied. And if we do the next two, it will continue the flow. Got it? So the next two are very simple, ABCD and ABCA. And now we will try to figure out why the aliens are saying that ABCD should appear before ABCA in their dictionary. And if we carefully observe AA, if we carefully have an observation AA, then BB same, CC. So all these English alphabets are same, but where is the difference? D tends to appear before A. D tends to appear before A. So I'll be like, okay, fine. D is tending to appear before A. So probably I'll say D tends to appear before A. So I can have an edge from D to A now. Perfect. Done. What is the next two guys? The next two guys are very simple. ABCA and CAB. So I'm saying, okay, in the dictionary we have ABCA and CAB. Now I need to ask the aliens, why are they thinking ABCA to be before CAB? They'll tell me because in the dictionary, A appears before C. In the dictionary, A appears before C. So can I say there is an edge between from A to B? So I can definitely see that there is an edge between A to C, rather not B, C. Okay, done. Let's take the next guys. What are the next guys? CAB, CAD, because that is what we have. The last pairs, CAB, CAD. So what we are saying is, hey, listen, CAB appears before CAD in the alien dictionary. Why? Because B is apparently smaller than D according to them, not according to me. According to them, B is smaller than D, which means B is smaller than D means there's an edge between B to D. There's an edge between B to D. So I can have something like this. There's an edge between B to D. Got it? So once you've done this, we're pretty much done. So we have created the directed graph. If you carefully see, we have created the directed graph. Now, assume if there was something like k equal to 5, then there would have been an alphabet as E as well, which would have been 4, right? Which would have been 4. There would have been an alphabet as E as well, which would have been 4. So where does that E lie in this DG? Because we do not have a mention of E, but the alphabets are saying we have 5 alphabets. We do not have a mention of E. In that case, we can consider the E to be a single. Yes, we can consider the E to be a single node in the DG, a single node in the DG. So this can lie anywhere in the order because this is not related. So if there are multiple components, doesn't matter. If someone is not related, doesn't matter. You can keep them as single. What matters is you pick up pairs, you pick up pairs, you pick up pairs, you pick up pairs. Find who is appearing before whom, and you make edges and you create the DG. And the ones that are left out will be single nodes. Once the DG is created, What do I need? Yes, what do I need? I need an order. So how do I get the order? There's only one algorithm that gives us the order. We perform the topological sort. The topological wills, because over here it clearly states A is smaller than C, or A must appear before C in the order. And that is where the topological sort comes in. If you figure out the topological sort of this, you will definitely get something like B at first. That's what you'll get, B. Then you'll get something like D. Then you'll get something like A. Then you'll get something like C. B, D, A, C is the topo sort. And if you include E, then you can add E over here or at the front, wherever you wish to. But if you perform the topological sort of this particular directed acyclic graph, you will get something like BDA, CE as the topological sort. Now, how do you implement this? We have seen like we have taken BDA, but instead of storing BDA, we will store something like 0, 1, 2, 3. It's a very simple thing. So the core concept lies, if we can figure out between every pair, who is appearing before whom, like who is the differentiating factor? Why is BAA before ABCD? That's because B is lesser than A. If I can figure out this differentiating factor, and if I can create the DG, then the question boils down to finding the topo sort of the DG. That is as simple as it gets. So can I say, in order to find out the differentiating factor between these two guys, so first I'll be like BAA, ABCD. Next I'll be like ABCD, ABCA. Next I'll be like ABCA, CAB. Next I'll be like CAB, CAD. Can I say I can run a loop? Yes, I can run a loop something like I equal to 0 till this guy, which is till 3. And what I'll do is, first time I will be at BAA. So I can say something like, okay, S1 is, let's say, array of I, which means BAA, which means it will be BAA. So I'll just erase it and explain how do you implement this. And I can say S2 to be array of I plus 1, which means it will be ABCD. So this is how, for the first time when I is 0, it will pick up array of I BAA and array of I plus 1, which is ABCD. It'll pick up. Now what you need to do is, you need to take these two strings and compare. B is equal to A. No. The moment you find a non-equality, you say, I don't need any further non-equalities in the future. B is smaller than A, and that is what determines for the dictionary to work. So I will just go ahead and say, add an edge between B and A, and I'll stop. So this is what happens for the first time when I is 0. Next time when I is 1, what you'll do is, this will change. Yes, this will definitely change. And this time what will happen is, you will get ABCD because I is 1, and ABCA. This is what will happen because I is 1. So you'll get this and this. Now if you start comparing, you just have an iterator, something like pointer. So this is equal, this is equal, this is equal, this is equal. Sorry, this will be A, not my bad. So when I is 1, you get ABCD, and for this 2, you'll get ABCA. So now what will happen is A equal, BB equal, CC equal. So D and A are the differentiating factor. So you'll go ahead and add the edge DA to your graph. Similarly, when I will be next time 2, what will happen? It'll get the next guy, ABCA. Yes, ABCA. I'll get something like CAB. So you can just go on every pair by pair. And after you have gone pair by pair, you just take a pointer and you compare. First time you get a differentiation. You say there is an edge between A and C, and you stop because you just need one guy to be the differentiating factor to place them in a dictionary order. So guys, I hope you've understood the solution. Now it's time to code it up. So as usual, I'll be coding the C++ on the right, and you can figure out the Java code on the left. So what are we given? We're given the dictionary, the number of strings and the number of alphabets that we will take from the English alphabet. So the first thing that I'll do is I'll try to create the adjacency list, and that will be for case size. Next, I know that I have to go through this dictionary. So I'll go through this dictionary till n-1 because I need pairs. The first string that I'll get is dictionary of I, and the second string that I'll get is dictionary of I plus 1. Why till n-1? Because you need pairs, and if you have to take the next one, you just go to second last, not to the last, because at last there will be no one else to compare, right? This is done. Now I need to compare every character, first character, second character, third character, fourth character. So I can go on till the length of minimum of S1 dot size, like whoever is minimal, I'll go on comparing till it. I can take it something like this. Because if there is one string this small, if there is one string this big, then we compare till the length of the smaller string. Got it? So for int, you can say ptr equal to 0 and pointer, and ptr is lesser than the length and ptr plus plus. So what I'll say is, hey, listen, if s1 of ptr is like both the characters are different, which is not equal to s2 of ptr, if both the characters are different, what you do is you say adjacency of, I'm saying someone appears before someone. So S1 of PTR appears before. S1 of PTR should be done as pushback of S2 of PTR. Simple as that. That's the thing you'll do. Now, you're saying S1 has an edge, directed edge to S2. S1 should appear before S2. That is valid because in dictionary it appears before. But I need to store in terms of 0, 1, 2. So just subtract minus A so that it automatically gets converted into 0, 1, 2. This is how you can easily create the graph. Now, once your graph is ready by performing this constructive algorithm, what do you need? You need to find its toposort of this directed graph, because they've clearly stated answer like ordering is possible. If they would have stated that answer is not possible, we will discuss it afterwards. But as of now, what I'll go is, I'll go ahead and pick up the function that gives me toposort. Okay. I'll just pick up the function that gives me toposort. We have already done this. So in case you have not checked out the previous videos, please check out for toposort. We have already done the toposort for any given directed graph with multiple components. Remember, this works for multiple components as well, for single nodes as well. So we just pick up the toposort that we have learned in the previous videos. Now what I'll say is, okay, listen, we have the graph. Can I ask this guy to give me the toposort? And what does he need? Needs the number of vertices and the graph. I'll give him the number of vertices. Remember, the number of vertices is not n. N is the number of words in the dictionary. The number of vertices is k, and I give him the adjacency list. Once I get this, also they're asking you to return a string, not a vector of int. So let's convert this into a string. String of answer equal to this, and I'll just go across the it of topo. And I know answer is equal to answer plus. I need to convert this into a character. So it is the alphabet. If you remember, we subtracted a. So you'll again add a so that we get the character back. And once you have got the character back, you can go ahead and return the answer, because they require a string to be returned. So go and compile it. So in this time you compile, you see this is running absolutely fine. Let's quickly submit this. And if you submit this, you will see that all the test cases are. So we have solved this particular problem. Now, what if the interviewer tweaks the question and says, okay, this was when this was always possible. Now, when the order will not be possible? What if the order is not possible? What if the dictionary is wrong? What if the order is not possible? How will you figure that out? So you'll tell him two test cases. One of the test cases you can say him is if the string 1 is this and string 2 is this. Whenever we try to compare the strings, what are we looking at? We are looking at, is this matching? Is this matching? Is this matching? And apparently you ended up comparing, like the comparison has gone, is finished. And you did not find a differentiating point because A, B, C, everything is matching. If everything is matching, doesn't matter if you're following the alien dictionary or if you're following the normal dictionary. The shorter string ABC should have been before ABCD for sure. So you can say this test case that if everything is matching and the larger string is before the shorter string, very important. If ABC was before ABCD, then that is fine. You don't need to find an order for this. But if the larger string is before the shorter string, when everyone matches, it's a no. Order is not possible. It's a wrong dictionary. Got it? And the other one is if you have something like which creates a cyclic dependency, something like ABC, something like BAT, and something like ADE. Now, what we are saying over here is we are saying A to be smaller than B, and we are saying B to be smaller than A. It's a cyclic dependency. This is not possible. So these are the two test cases when a dictionary is wrong. When a dictionary is wrong. Whenever you find two pairs having something like this or a cyclic dependency, because we know for a cycle, topo sort or any sorted order is not possible. That is what you'll tell the interviewer. If he gives you a follow-up question that when is it not possible, you tell them, listen, if the largest string appears before the shorter and everything is matching, not possible. If there's a cyclic dependency, not possible. These are the two checks you have to integrate in the given code and it will start running absolutely fine. So guys, I hope I was able to explain you this particular problem. So just in case I was, please hit that like button, and if you're new to our channel, please do consider subscribing to us. And if you haven't checked out our DP series and the SD sheet, the links are in the description. And yeah, with this, I'll be wrapping up this video. Let's meet in some other video. Till then, bye-bye. Take care.
Whenever your heart is broken, don't ever forget you're golden.